All right, hey everyone, Stat 13 crew, welcome back. So for this video, we're going to start talking about finding probabilities with this normal distribution, and the idea of finding a probability is going to be extremely connected to this percentile idea that we had just talked about. And so again, for now, we still haven't used StatKey. We'll get to that next. For now, I'm at the top of page 6, and we're going to change examples to this US newborn baby weight example. And so we're going to suppose, like before, that the baby weights of newborns in the US are normally distributed with a mean of 7 and a standard deviation of 2. And so let's figure out then what the probability is that a woman delivers a baby who weighs more than 12 pounds. So this poor woman. Let's find that probability and hope that it's really small because that sounds awful. And so the mean here is 7. Standard deviation is 2, so that's what I'm going to use for my tick marks with that 68, 95, 99 rule kind of as an approximate guide. And so what we want to do then is figure out the probability that a baby weighs more than 12 pounds, so 12 is right here. And a probability is going to be that it's more than 12 pounds is going to be the area shaded to the right of that. So if we wanted to find the probability that a baby weighed less than 12 pounds, then we'd shade all this area to the left. And so we said at the very beginning that the area under this curve was 1. So that kind of relates to this probability stuff. Because we know that we can't have a probability bigger than 1, or we know that the chance of something occurring can't be more than 100%. And so I'm just going to guess what this probability is as being, I don't know, 0.05, because that looks like the area that's shaded is about 5% of the entire area under the curve. But in the next video, we're going to use StatKey to actually find that exact probability. So we'll come back to this as well, and I'm going to mark it with a little question mark. Okay, and so let's kind of do a couple more examples just to get the hang of this. So let's find the z-score of a woman who gives birth to a 6.4 pound baby. So it's much better than 12 pounds, and I can't imagine, though. I don't have experience myself, obviously. And so our z-score is going to be the baby weight minus the mean divided by the standard deviation. If you do that calculation, you'd get negative 0.3. That makes sense because her baby is less pounds than the mean, so the negative sign makes sense there. We can also figure out what percent of newborns weigh less than 6.4 pounds. So I'm going to come back here to my picture. Going to mark 6.4 there. And then the percent that weigh less, to me, that looks like it's about 45%. Question mark. So this relates directly to probability in that the probability that a newborn baby weighs less than 6.4 pounds is 0.45. And so it's percentiles and probabilities are very closely related. The 45th percentile means that the probability that someone, in this case that some baby weighs less than that, is 0.45. And finally, we're going to talk about this question that, again, we'll come back to this in hypothesis testing and informal statistical analysis. So it seems like kind of out of place here and kind of like, well, what's the point of talking about this? But we'll see its use a little bit later. And so the question is a 6.4-pound baby or a 12-pound baby more unusual? And what we want to do to answer that is we just want to see which value is farther into a tail. Because if it's farther into a tail on either end, that means that it's pretty unusual. Whereas something that's like near the mean or near 7, that's not really unusual at all. That's very close to what the typical average baby weight is. And so in this case, we could kind of easily see that the 12-pound baby of that poor mother is more unusual. We could answer this why in a couple ways. Both really mean the same thing. So more unusual because 12 is farther into a tail of the distribution than 6.4. We can also answer this using z-scores and say something like the 12-pound baby z-score is farther from 0 than the 6.4-pound baby z-score. And so therefore, it's more standard deviations away from the mean. So both of these are really saying the same thing. One's just using the graph, the other is using the concept of z-scores that we talked about. All right, and so for the next video, we'll come back and get some exact answers to these, as well as some exact answers to these percentile questions using StatKey.